Szaby and I are in a small startup, which is a health startup. And we've been doing this for about 6 months now, working together on this. We've got professional history together, so we both know our pros and cons. And when we decided to work together on this startup, we chose Kotlin, and it's new to me. And so I frankly am only 6 months into Kotlin, but I'm loving it, having spent many, many years writing Java. And I'm very pleased not to be having to use Lombok or all sorts of other tricks to work around the verbosity of Java. So I've been coding for very many years, and although I have a grand title of Chief Technology Officer, I'm still very much a hands-on kind of person. I'll hand over to Szaby to give you a bit of his professional introduction.
Hi, my name is Szaby, and indeed, I have spent countless years in the Java scene myself. I think I was the one who introduced you to Lombok as well. Before that, there were like fat data classes in Java. So we have worked together with Andrew in a different company in commercial setting, and we enjoyed each other's company. So we joined up in this startup where I enjoyed the title of head of engineering. And Andrew's going to give you a short introduction, what this company does and what we are into at the moment.
Okay, so I'm not going to tell you too much about the health aspect. We help people who are suffering from diabetes or are living with obesity to help overcome that medical condition. That's it for the sales speech about my company. We are 12 developers, and we're using a mixture of React Native, and Kotlin, and 5 of us are coding in Kotlin. And so we've chosen to use Spring, and we'll talk a little bit more about that in a moment. Overall, our technical stack is this. So we're building microservices to support the front ends, the 2 types of front ends. So I expect some of you who are listening are using Kotlin in mobile devices. That's not what we're doing. We chose not to use that. We're using React, as you can tell, but Kotlin is what we're using on the server side. So just pretty much traditional server-side programming. We're not doing any cross-platform or anything wonderful like that. Straightforward in-out replacement for where you'd normally use Java. Because of our heritage of using the Java ecosystem, we were both very familiar with Spring and those kind of things. So we wanted to use Spring, and of course, Spring, as you must know, is treats Kotlin as a first-class citizen. It's got all sorts of extensions and things for that. We're using those other technologies on the screen. So what we wanted to do if we're creating microservices is to be able to validate the inputs inputs that come into a REST interface. And if using Spring, the go-to kind of technologies there are provided by the Spring framework. And there you have these annotations like @valid and @validated, very similar names, pretty confusing that they're so close. And you pass off validation to a library such as Hibernate's library. And this is okay, but what we found was, well, it's certainly well documented, and a Java developer who's come from Spring world is pretty likely to have heard about it. But we felt it was rather clumsy. You can do field by field validation, okay, but you can't often do composite validation where you want some logic which says, well, if this value in this field is such and such, then you switch on the validation of another range of fields, those kind of things. Yes, it's got a group facility, the Spring JSR type thing, but it was kind of like a mixture of code. You have to create annotation classes and then implementations. And it was all over the place. And we thought, isn't it time we looked for something that was a Kotlin first solution, something that could also deal with Kotlin's nulls, so or the way that Kotlin is sort of fixated about having non-nullable fields. When data goes into a data object in the Spring framework, it tries to use the constructor to fill the data out. And if that data is not present, then you'll get a null pointer exception type thing on the constructor. So it doesn't play very nicely at all to use that kind of model. So we wanted to try and find something else. We would prefer if it was a Kotlin native solution and written in a nice sort of DSL would be what we were looking for. So off we went and did a bit of research. And I recommend, and this article, I'll provide the links at the end of the talk as well. This guy, Emmanuel, provided a comparison of 5 pretty good libraries, and he tried them all out. And at the bottom, number 5, he recommended Conform, and that was the one that appealed to us the most. And so this is the one we've gone with. I appreciate it's not very well known. It doesn't have very many forks or stars on GitHub, but as you know, Kotlin is an emerging language, and so it's not going to have anything like the same following as something like Spring. Anyway, we decided we would have a go at it, and what we're now going to try and demonstrate is how it works. So hopefully you can see my IntelliJ interface. So I've got a data class called post1request that contains a name and a profile. And I will explain this syntax in a moment. Let's for the moment imagine that profile type is an enum, or should be an enum, and name is a string, but both of these should be mandatory. So the first question is, well, why have I got these optional markers, the question marks? Well, this is because, as I say, when you ask Spring to fill out this request object, it might be that the caller omits to send name or profile type. And what we want to do is to provide a nice message to the caller to say, you need to provide the name or you need to provide the profile type. And if you do not make this optional, then Spring kind of crashes too early in the cycle for anything to happen. And you just get an error which says, well, I can't construct this Kotlin data class because one of the fields is currently null. So we wanted to allow, we wanted to be able to deal with that kind of problem. We also wanted to collect together any errors that might occur in the fields and present them all in one go. So I don't want to, if someone is submitting a form with 10 fields, I don't want to have 10 individual messages, one after the other. I'd like to see all the errors that I've got in one go. That was one of our design goals. So Conform allows us to do this kind of thing. So for the moment, and this is not necessarily how we ended up implementing it, but you create a syntax like this. You refer to the class name and then this field declaration like this. And then this is now some of the built-in functions of the Kotlin, so the Conform library. So as you can probably guess, this is going to require name to be present and have a minimum length, and profile type is a required field. And well, the difference between if present and required is that the validation will not proceed inside those brackets if the value is null. If it has a value, then it checks what the rules are inside the brackets. Where in contrast, the profile type is always required. And then there's got some a feature here where it allows it to check that this profile type string is a member of the enum here. So let's try this out. So I'm going to use terminal REPL for Kotlin, and I'm going to put in the syntax. Before I execute this, so this is a reference to this object. I'm constructing it with 2 strings, member and Andrew, and then I'm going to call this validate function. Now, I happen to know that this is a valid member of the profile type, and this is a string that meets the criteria that it's two or more characters. So this is going to pass. So I'll show you what happens now. So I get a validation result object from the Conform library that just says, yep, that's valid. And then it's got some sort of toString inside there. So let's break it. Let's do the same thing, but let's put this as a single character, which we know is going to break this min length rule. And so now I get a collection of errors. You can see there's a start of an array here. And then automatically out of the box, it's done things like determined the path within this data object with the field name. And then it's created this message here, must have at least 2 characters. So it's done quite a bit of work for us in that. Now let's try and break the enum. So I know that I know that XX is not a valid value. And then we get 2 elements in the array. And so I've got the second error, and it says this profile type must be a member of those enums. So this is pretty much what we wanted. We wanted to be able to do multi-field validation. We're using a simple syntax, and you can do more than single validation in one go, of course. I could have max length, for example. Let's take that to be 6. And if we put this in again, and this time I put, this is going to exceed the max length, and you can see, did I do that correctly? Did I count right? Someone's gonna help me out here with live. What have I done? Okay, Sabby, what have I done wrong? All good demos are bound to fail. I don't know what the problem with that is, but I will show you later that we've got plenty of these multiple validators in here. So now let's make it a bit more fun. Let's bring it into Spring and a controller. So I've got a controller ready to go. And you see that what I did is I constructed the object, which I'm expecting Spring to do for me, and then I called the validate method. So I've got a controller here which does pretty much what we want. So standard Spring REST controller is going to listen to some kind of endpoint for a post mapping on this. Then I declare the request body should be mapped into this data object. I'm going to print it on the screen. I'm then going to call the validate method. Then I'm going to check to see if it's invalid. If it's invalid, I'm going to convert the messages into a format that I would like, which is done by this method down here, or I'll produce a nice message over there. So let's run the application and see what happens. So here is the URL, and this is a correct payload ready to go. And I hit the button, and we get a nice 200 post request here. And looking back in the code, we're expecting to see the received object. There's the received object. That's all good. So now what happens if we break it? So I'm going to break it in the same way. I'm going to put a short name and an incorrect profile type, hit the button, and now it's presented this in a nice JSON format, which conforms to what we were trying to deliver to our RESTful clients. So that's kind of basically the job done of that framework. However, this is really pretty ugly, this code. I would like, if we could get this to be a bit smaller. So I don't want to have to do all this every time. Is there a better way that we could make it work a bit like in Spring? You'd type you type @ ampersand valid or ampersand validated. So over now to Szaby, who should be able to explain how we got this to be improved and far less lines of code in the controller.
Yes. So thanks for that, Andrew. So one of the things we realized early that the boilerplate code for this kind of validation, like Andrew pointed out, would be pretty lengthy in every controller. So to automate this and preferably do it in a way that it sits well with Spring, we chose the same mechanism what Spring uses to do the JSR 303 validations. Which is Spring has an aspect decorator framework where you can use aspect to decorate any kind of objects, and Spring will create a proxy object. So this is AOP, aspect-oriented programming, but Spring provides a specific framework for that. Let me bring up my control of that IDE, what you see, hopefully. Can you see the screen changing?
I'm following you. So if
Are you? Yeah. Okay. So this is the way you basically do this. In Spring, there's a abstract beam factory aware advising post-processor, simple name, right? Where you can declare a matching point cut. In our case, there's an annotation we created for this purpose, which is k-validated. It mimics the validated annotation from the JSR 303 framework. It's just k-validated. And then it defines an advisor for this point cut, which will be our k-validation interceptor. This is what's doing the real work. So this interceptor is a method interceptor. What it means in AOP terms, this is an around point cut. So we will get the core intercepted prior to the method execution, and we will get back control after the execution. We will get information about the actual invocation, the method invocation, and this is the only function we need to override. So what we did here is all that logic to go through the method, inspect the method where we want to do validation, and if the method contains any parameters or input or output values which implements a specific interface, which I'm going to show you in a second, then we're going to perform automatic validation. And we made it smart enough that if there's validation errors and the invoked method responds with a response entity, meaning it's a controller with a response entity, a response type, then we will create that nice object that you've seen previously on the Postman calls. So we will automatically convert it to proper errors. If it's not, then we will just bubble up an exception. Now, the nice thing about this is that you not only can do validation on parameters of REST score, you can do pass parameter validation as well, which normally would be more difficult to do. And you can do validation on return values as well, because this is the method, this is the actual method. And like I said, we get back control after the method executed, and we can inspect the returned value as well. And if it's something we call validatable, and I'm going to show you this in a second, if it's something validatable, then we instantly know that this interface, because it forces out the conform function to be implemented, we know that it can be validated, and we will do the validation and collate the error responses and serve it back to the user. There are other scenarios where you don't respond with the response entity, you respond with a hard object and so on. So we handle all those cases as well. So it's as seamless as it gets, which I'm sure we will have a demo controller to show this in a second. Another thing I wanted to talk about that, let's say, what was that? The demo controller one. Let's see. We've seen one thing, the model in here, and what we felt to sort of emphasize how important that is, that the validation logic sits together with the data class being validated. So you don't have to implement a separate validator, which you would normally do with the JavaX validation, so the GSR 303. You would implement a validator class, and then you would annotate your model to be validated by that validator class, and so on. So the logic would be separate from the data being validated. And it's a little bit cumbersome. So what we really have is the data class, the model being validated, sits together with the validation logic, right? So almost like inseparable. Now, this demo model right here, it's implementing a function, but as you see, there's no interfaces. It's just implements a validate function. To make sure that the validation framework of ours can pick this up, what we do is we have an interface called validatable, and this enforces a single validate function to be implemented, and this way we can also pick it up in the AOP code that a data class is validatable. That means you don't have to do anything, just like with the normal GSR validation. You don't have to go into lengths to annotate every single parameter in your controller. You get that sort of validation automatically. So how this looks is you decorate your controller just with one K-validated marker annotation, and then the AOP framework will kick in because the point cut is looking for this marker annotation. That means that this controller is subject to validation. You could attach this, of course, to a function, just like you can with a request mapping or any other annotation, but you can do it on a class level. If you do it on a class level, the framework will look for any parameter, for example, this one, which implements the validatable interface. And if it's validatable, it will perform validation. If your response is validatable, this is now any, but say this would say here post one response, and that's also implements validation, you could validate response. Now, you might ask, what's the point for validating responses? Maybe not much, but if you, in a microservices world, if you get into the habit of validating every model you have, then if you call a downstream service and then you rely that it produces the right values, and then you just serve back whatever you got from a downstream service, you might find errors very quickly if the downstream service serve, let's say, a non-compliant answer, right? You right away get back validation errors, and you're like, hey, I just called this service and it gave me something that's not supposed to. So we are pretty happy how this with how this turned out in the end, I would think. And I don't know if we have a case in the demo controllers here, but if you would do something like this, and you would say naturally that I don't know, path param string, and then you would say this is a sorry, typo, path variable ID, something like this, right? If you have something like this now, and this class is implementing the marker interface, the validator bar, you would still be able to validate this. So this is quite important for us because I'm not sure if Andrew is going to talk about that. We use a composite object for ID. So what we use here is not a normal string. We parse this into a complex model. So our IDs only valid if they are the right length and the timestamp within. There's an encoded timestamp in there, and the timestamp parses correctly, and so on. So there are certain IDs which are not valid, even though. So you can describe whether they are valid or not just by looking at their string form. They need to be. You need to be able to parse them to the right object, and we call that rulets in our case. And these IDs, I don't think it's subject for the discussion, but these IDs are pretty difficult to validate unless you construct a ruled object from them. Now, if you use these IDs in the pass parameters, how do you validate them, right? That's a difficult question because you could only do that inside the function bodies with additional logic. But this allows us to do just that because our ruled object implements validator. And every time we use a ruled anywhere, we will be able to validate that, right? So there's certain benefits to this approach. And then I think that leads us onto the part where we are not so happy, or what are the things that remain, right? Andrew, you want to take it from here?
Yep. So let's show you some real life examples of what this looks like in our code base. So if I look for, so this is a object that's used to create a profile. So we got lots of different fields. And as you can see, they're all string ? Because that's what we need to do to allow Spring to be able to populate it with something. But something like sex at birth is an enum. This is an enum. There might be a date of birth is a date. So there's lots of complex examples in here. And this is what the validation looks like. Very readable stuff. The known as field, if it's present, make sure it looks like a name. Sex at birth, make sure it conforms to the sex enum. In the case of date of birth, run this validation function. And so you can see we've used validate name quite a few times. If I can drill into that, you can see you can enclose that, encapsulate that logic in a little tiny function. You can nest things as we've got here. So an address object in turn contains different things. So it gets to be quite nice that you can write all of your validation in that code like that. So that's what we really liked about it. Now, let's talk about some of the disadvantages, perhaps. If I show you, this is one of our very first request objects we used, and we then incorporated that into a profile service. And this is the use of the profile service. I'm not showing the controller, but the controller passes it to the service in the usual kind of manner. Here comes the request object. And now it's used to construct the real object, which in our case is called a member. But you see lots of this double exclamation mark hell, which is, whatever. I know it's not going to be null because I've checked it, but it looks pretty ugly. And then when you've got something like an enum, we've still got all of this stuff in here. So this now jars with the solution, because now you've strayed all your nasty strings out into this class, and you've got to, or optional strings, and then you've got strings here you've got to convert into a type. Could we do something better? Well, the next evolution of this is in something like this class, where this has got four apparent strings, but I can tell you that these three are really enums, and you can tell from the validation here, enum. This started date, you can guess from the name, is going to be a date time, and so we've got a validator for that. And this is the nice juicy next bit, is that we've got a function here called convert to data object, which does the type conversion into the strong, well-typed Kotlin subscription class. now we've got even better. We've encapsulated inside this one place all the type conversion noise. And all you've got to do is to ask for this profile subscription put request thing to be populated by the Spring framework. It will then automatically run the validator because I've got this annotation on here. And then I can just say .convert to data object. And now I get a strongly typed object out of it. And if I've reached that point in the code, I know it will be a well-formed, a valid object. So that's how we've got over that little objection. Let's look to see. Yeah, I think we can now go back to the slides. So these are, we're almost at the end now, and this is what we conclude are the pros and cons of the two systems. Conform gives us an elegant Kotlin way of doing things. Standard idiomatic kind of ways of doing it. We can encapsulate the validation inside the handling class, the request class. There's a whole array of standard validators. We haven't had to go stray too far from that yet. Let me show you one other one. If we look at, yeah, we've got some things in our validation sort of. Yeah, here we go. We've got, that's a horrible email validation. I'm sure everyone's got one of those. So we've got a way of encapsulating email validations, name layouts and sex at birth, all these kind of things. So we've got a bunch of our own validators that are related to our particular data types or data structures. Other than that, we found that Conform has got anything that we need. As you can tell by this, they do support regex, so that gets you out a lot of holes straight away. We found it's very easy to extend the validation, as I showed you. So what are the disadvantages? Well, there's no Spring integration, except Szaby showed that with a couple of complex classes, we've now solved that. Have we encapsulated to type conversion and dealt with Kotlin's nulls? Well, it still feels a bit sort of dirty to me, having to do all this question mark stuff. But given that that's the nature of the Kotlin beast, and given that we can put this sort of type conversion inside, I think we've gone as far as we can now with Conform to hide these kind of problems about the encapsulation and dealing with nulls. So we're pretty happy with it. None of us knew about Conform, none of the 5 developers, and everyone seems to have understood it, and it's been quite easy to roll out. So,
sorry, Andrew, may I just add something? Sorry, we got a comment in the chat about exactly the stuff we are also experimenting with it. So if you would just look at the contract stuff we've been doing, one of our viewers mentioned that when contracts will no longer be experimental, we can get rid of the double exclamation mark. So we indeed have a couple of experimental contracts in our code just around this. But like you say, it's indeed, right now, it's not a mainstream feature. And there are limits to what the Kotlin compiler, to what length it goes to figure out the contracts. So we find that it's kind of a hit and miss. But yeah, if that support will be stronger, I guess that will be helpful.